Following illustration shows schematic representation of CNN and RNN. Input frame CNN in per frame. Input frame CNN output estimate output coming. Input frame. In Bayesian filters, CNN, KF, PF seriously connected. Input video, output tracks coming. Here input video CNN RN connecting in series method. Sorry, in parallel shunt method. Here input video CNN RNN connected through series method. Output tracks. Then 15th chapter TensorFlow. Keras. Keras is compact, easy to learn, high-level Python library, run on top of TensorFlow framework. It is made with the focus of understanding deep learning techniques such as creating layers for neural networks, maintaining the concepts of shapes and the mathematical details. The creation of framework can be of the following two types. First one, sequential API. Second one, functional API. Consider the following 8 steps to create deep learning model in Keras. Loading the data. Pre-process the loaded data. Definition of model. Compiling the model. Fit the specified model. Evaluate it. Make the required predictions. Save the model. We will use Jupyter Notebook for execution and display of output as shown below. Step 1. Loading the data and pre-processing. The loaded data is implemented first to execute the deep learning model. Import warnings. Warnings filtering. Ignore. Import numpy as np. 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 np random seed 123 for reproducibility. From Keras models, import sequential. From Keras layers, import flatten. Max full 2D. Conversion 2D. Tens reshape dropout. From Keras utilities, import np. That is numpy utils. Using TensorFlow backend from Keras datasets import MNIST. Load pre-shuffled MNIST data into train and test sets. X train, Y train, X test, Y test. MN equal to MNIST load data. X train equal to X train, reshape X train, shape 0, 28, 28, 1. X test, reshape, X test shape 0, 28, 28, 1. X train, X test. In X train, AS type float 32. X test equal to X test as type float 32. X train equal to 255. X test equal to 255. Y train NP utils to categorical Y train, 10. Y test NP utils to categorically Y test 10. The step can be defined as import libraries, models, which means all the libraries and the modules are imported as an initial step. Step 2. In this step, we will define the model architecture. Model equal to sequential open close bracket model dot add conversion to the 32 of 32 3 3 activation equal to ReLU input shape 28 1 model add conversion to the same 32 3 3 activation ReLU model add here maximum pool to the pool size 2, 2 model add dropout of 0.25 model add flatten model add tens 128 activation equal to RLU model add dropout 0.5 model add tens 10 activation softmax. Step 3. Let us now compile the specified model. Model compile loss categorical cross entropy optimizer equal to Adam matrix accuracy. Then step 4. We will now fit the model using training data model fit of x train, y train, batch size equal to 32, epoch 10, verbose equal to 1. The output of iterations created is as follows. Epoch 1 by 10, 60,000 divided 60,000 minus 65s plus 0.2124 accuracy 0.9345 epoch 2 by 10 60,000 divided 60,000 minus 62 years loss 0.0893 accuracy 0.9740 epoch 3 by 10 60,000 divided 60,000 50 years loss 0.0665 accuracy 0.9802 epoch 9 by 4 by 10 60 and 60,000 divided 60,000 62 years loss 0.0571 accuracy 0.9380 epoch 5 by 10 60,000 divided by 60,000 62 years loss 0.0474 accuracy 0.9855 epoch 6 by 10 60,000 divided 60,000 59 years loss 0.0416 accuracy 0.9871 epoch 7 by 10 60,000 divided 60,000 61 LS loss 0.0380 accuracy 9877 epoch 8 by 10 60,000 divided by 60,000 63 years loss 0.0333 accuracy 0.9895 epoch 9 by 10 60,000 60,000 same 64 years loss 0.0325 accuracy 0.9898 epoch 10 by 10 60,000 60,000 divided by 60,000 divided by 60,000 60 years loss 0.0284 accuracy 0.9910 then next chapter TensorFlow distributed computing. This chapter will focus on how to get started with the distributed TensorFlow. The aim is to help developers understand the basic distributed TensorFlow concepts that are recurring, such as TF server. We will use the Jupyter notebook for evaluating distributed TensorFlow. The implementation of distributed computing with the TensorFlow is mentioned below. Import the necessary modules mandatory for distributed computing. Import TensorFlow as TF. Step 2. Create TensorFlow cluster with one node. Let us consider node be responsible for a job that has name worker and that will operate on take at localhost 2222 times 2. Cluster specification tf.train cluster specification of open bracket parenthesis worker localhost equal to 4 times server tf train server cluster specification server target. The above scripts generate the following output: grbc localhost 4 times 2. The server is currently running. Step 3. The server configuration with respect to session can be calculated by executing the following command: server.server underscore def. The above command generates the following output: cluster for job name worker task value localhost 4 times 2 job name worker. Protocol gRPC. Step 4. Launch a TensorFlow session with the execution engine being the server. Use TensorFlow to create local server and use ISOF to find out the location of the server. Session tf.session target server target server tf train server create a local server. Step 5. Few devices available in this session and close the respective session. Devices sessional dot list devices for D in devices printed D name session close. The above command generates the following output: job colon worker slash replica colon 0 slash task colon 0 slash device colon CPU colon theta. TensorFlow. Next chapter TensorFlow exporting with TensorFlow. Here we will focus on metagraph formation in TensorFlow. This will help us understand export module in TensorFlow. The metagraph contains the basic information which is required to train, perform evaluation or run inference on a previously trained graph. Following is the code snippet for the same. Definition: export metagraph file name none collection list and ask as text is equal to false. This code writes metagraph to save path file name. Arguments: file name equal to colon optimal metagraph file name including the path collection list of string keys to collect as text. If true, writes the metagraph as an ASCII photo. Returns a metagraph TC proto. One of the typical usage model for the same mentioned below. Build the model with the TF session as sessions. Use the model. Export the model to temporary. My model is metagraph TF train export metagraph file name tmp / my model meta. Then next chapter TensorFlow multi-layer production learning. Multi-layer perception, sorry, perceptron.